Welcome everybody to the beginning of section 2.8 in our workbook. This is page 86 that we're looking at. And the topic of this section is using derivatives to evaluate limits. Evaluating limits, that's something that we haven't done for a really long time in the course. Way back in the very first few weeks, we're going to revisit that topic in this section and discover that for certain types of limits, derivatives can actually help us to evaluate them. Okay, so before we do that, let's take a look at example 1 here together. That's going to give us a way just to review the idea of limits from a numerical and a graphical point of view. Okay, so notice that we're given a function here. Okay, f of x equals x squared plus 1 over x squared minus 1. And they're giving us the graph of the function so that we can kind of see how it looks. And I want to take a minute just to make a couple of graphical observations about this. You might have noticed that this function has some asymptotes. Okay, there's a vertical asymptote here at x equals 1. Kind of makes sense because the denominator of our function is 0 if we plug 1 in, and another vertical asymptote at negative 1. Okay, and there's also appears to be a horizontal asymptote at y equals 1. Okay, so we'll just kind of draw those in there. Okay, and now what about these limits? Okay, well, what I'd like to do is to just pick out a couple of these, okay, and see if we can do the limit using a table just to review that old method that we talked about a while ago. And let's start with part A here. Okay, so it would like us to calculate the limit as x approaches infinity of f of x. Remember what that's really saying again. Basically saying that as our values of x get closer and closer to infinity, in other words, as they get really, really big, it's asking us what's happening to the output values of the function. What are they approaching? Okay, and so we can approach a problem like that using a table. Okay, let's just review that method below here. Okay, so we'll make one row with the values of x that we're plugging in. Okay, and then another row with the outputs, f of x. And remember the formula for f of x that they gave us looked like this. All right, and now the question is, what kinds of values of x do we want to plug in here? What would make sense? Okay, well, remember what x is approaching. It's getting closer to infinity. So we need a list of numbers that's getting big. Okay, so you can choose any list of numbers you want to as long as they're getting bigger and bigger. I'm going to start with 5, 10, 100, and 1,000. Notice that those numbers are approaching infinity. And what we're interested in is what's happening down here in the second row. Okay, what are the outputs doing? So we'll do what we did earlier in the course and just substitute our x values in one at a time, maybe starting with the 5 here. So I'm going to go over to the right and just do a little side calculation. So we'll take that number 5, okay, plug it into our function, and you can double check my arithmetic here. If you do that calculation, you're going to get 1.08. Okay, and that's the first number that's going to go in our table down here. And the idea is just to repeat that calculation with each number one at a time. The next thing we do is to plug 10 into our function. Okay, and I'm trusting that you can do that calculation. Okay, I got 1.02 when I did that. And then we'd move over and plug in 100. That winds up being 1.0002. And then 1,000, lots of zeros here, 5 zeros and a 2. Okay, and the question we're asking is, as we look at that bottom row, what are those numbers approaching? 1.08, 1.02, 1.0002, and so on. You can kind of see that those numbers appear to be getting closer to 1. Okay. So if that's true, that should be the value of our limit back up here in part A. We have just made a guess that this limit is 1. Okay, I'd like to double check that guess with our graph. Does that number 1 that we got make graphical sense? Okay, so we're still looking at part A here. And let's think graphically about what this limit is saying. Again, x is approaching infinity, so which part of our graph would that refer to? Well, if x is big, we must be talking about what's happening over here at the right part of our graph. So we'll find a point that's kind of close to the right side of our graph, and we'll slide towards x equals infinity. And my question to you is, what does it look like the y values are approaching as we do that? Okay, well, you can see they're kind of getting closer to this horizontal asymptote, which has a value of y equals 1. That number 1 confirms the answer that we got again. Okay, good. So I think we're good on the limit in part A. So let's move on to a different one. I'd like to jump down and see if we can do part E now. Okay, we'll scroll down a bit. And we'll do what we did before. We'll first try to make a table. Okay, function hasn't changed. Now the only thing that's different in E is what x is approaching. This time x is approaching 1 from the right. Okay, so that means we're interested in what happens for x values that are a little bit bigger than 1. So when we choose our x values this time, we're going to choose them to be a little bit bigger than 1. We might start with a number like 1.1. Okay, and then a number that's still bigger than 1 but a little closer would be 1.01. Okay, and so on. You might remember doing problems like this way back earlier in the course. Okay, and we're going to do the same thing we did above, just take those numbers and substitute into our function, starting with 1.1. Okay, so 1.1 squared plus 1 over 1.1 squared minus 1. If you do that calculation, you're going to get 10.5. You can try that on your calculator. Okay, and you'd move over and try it for 1.01. That ends up being 100.5. And then 1,000.5, and then 10,000.5. And the question again is, what are these numbers approaching? Okay, down here in the second row. Okay, well, you can look and see that they're getting bigger, so they appear to be approaching infinity. Okay, and so if we've done everything right, that should be the value of our limit up here in part E. Okay, does that make graphical sense? Let's see if we can confirm that from our graph. So if x approaches 1 from the right-hand side, we need to find the portion of our graph that's a little bit bigger than 1. Okay, so I'm going to pick a point here on our graph that's a little bit bigger than 1, and we want to slide towards x equals 1, which means we're going to be moving kind of up in this direction. Notice that those y values are getting bigger and bigger, and that confirms this answer of infinity that we have over here to the left. Okay, so let's see if we can fill in the remaining 4 limits that we haven't done here yet. We could make a table for all of these, but I think it would be quicker to use the graph, okay, to just try to come up with an estimate. So maybe starting with B here, this is the limit as x approaches negative infinity. So we're talking about x values that are really small, way over on the left-hand side of our graph. So we'll find a point that's close to the left edge. We're going to slide off towards negative infinity, and what does it look like the y values are approaching? Looks to me like we're approaching this horizontal line y equals 1 again. Okay, so that limit should be 1. Okay, and then moving on to C. Now x is approaching negative 1 from the right-hand side. Okay, so we want to be a little bit bigger than negative 1. So that would put us about here on the number line. Where is our graph? Well, it's down here. So there's a point where x is a little bit bigger than negative 1, and we want to slide towards negative 1, which is going to force us down in this direction. Notice the y values are getting really, really small and going off to negative infinity. Okay, and then we come to D. This time, x is approaching negative 1 from the left. Okay, so we're going to be a little smaller than -1. We'll find where our graph is, and we're going to approach -1. Okay, that's going to actually take us up in this direction. Notice that that's going to give us a value of infinity. Okay, and then finally, the last one, f is asking what is the limit as x approaches 1 from the left-hand side. So we're talking about x values that are a little bit less than 1 here. Find our graph, it's down here. And if we approach 1, this time we're headed off in this direction. Okay, and so it looks like we're going off to -infinity again. Okay, and it looks like we've finished this exercise. One thing that you might notice is that what's different here is there were infinities involved in these limits. Okay, this is the first time that infinity has been involved, and we'll see as we do future examples